Hey everyone, in this video series, let's take a look at the visual effect graph in Unity. With it, you can make some pretty amazing particle effects at runtime. Whereas the existing Shuriken particle system uses the CPU for its calculations, the new visual effect graph in 2018.3 and onwards uses the GPU. Instead of thousands of particles on screen, we literally can have millions, and we can create complex effects that previously would have been too slow to run in real time. Note that the new visual effect graph currently complements rather than replaces the existing Shuriken particle system. Depending on how you need the particles to interact with the game objects in your scene, you will still need to use both. Because the new system uses the GPU, it does not talk to Unity's underlying physics system when doing the simulations. But don't worry, they can both live side by side in the same project. You'll just need to decide on how they will apply to your scene before choosing what to use. The new visual effect graph has an interface similar to the shader graph, and though there are substantial differences, if you're already familiar with shader graph, you'll feel right at home here. Everything is entirely node-based and very flexible, borrowing from what visual effects artists in the film industry have been using for years. As of this recording, the visual effect graph only works with the high-definition render pipeline. The compute shaders required by this new system make it incompatible with a lot of devices like mobile phones, so bear that in mind. To start, let's create a new project using the HD render pipeline. In the Unity Hub, let's make a new project, select the HDRP template, and we can create a new scene. Open the package manager, select the visual effect graph package and install it. After a minute or so, we should see the package in our project. The workflow is to create two things: a visual effect graph asset in the project window and a visual effect object in the hierarchy. In my project, let's stay organized, and I'll create a folder called VFX graph demo. Inside of that, we can create the visual effect graph asset with the context menu, create visual effects, visual effect graph. I'll call it VFX graph. In this asset, we're going to set up all of the parameters and particles, etc. To play back the graph in the hierarchy, we'll need another game object and component called a visual effect object. Again, we'll generate that from the context menu. Right-click, visual effects, visual effect. Just note that this is a different entity than what we made in the project. To attach the graph from the project to the visual effect object in our hierarchy, you just drag it to the asset template field. Note that you can skip an extra step by dragging the visual effect graph asset directly into the hierarchy. It will create the visual effect object automatically and assign the graph to the first field. Just note that these are two different entities, the object in the hierarchy and the graph asset in the project. To edit how the particles look and behave, we need to go to the new UI, the visual effect graph editor. You can either double-click the graph asset in the project window to open that, or you can find it under Window, Visual Effects, Visual Effect Graph. Either method opens up this editor window, which you can dock like any other window in Unity. And remember, you can use the Shift plus Space hotkey combination to jump in and out of being maximized. That's handy for previewing your effect in the scene, and then switching to the window to make edits to the graph. Or you could just keep the window hovered. That's up to you. If you have a second monitor, that's usually a pretty good place to park the UI. Before we can actually make anything, we should learn the basics of the interface. As we mentioned before, it's very similar to, but not quite the same as shader graph. The visual effect graph is composed of these smaller elements that are connected with lines, and you'll notice that some of these elements are broken down into smaller units themselves. Our main vertical section of this graph is composed of rectangles that are labeled spawn, initialize, update, and quad output. Those are our context. A context is applied to the particles in order. Essentially, these operations run straight down from spawn to initialize to update and output. Those of you familiar with writing scripts in the Unity API understand that there's an order to the parts of a monobehavior. Just like a monobehavior has methods that define awake, start, update, the visual effects graph has operations that happen in order as well. The dotted line that surrounds the initialize, update, and quad output context is called a system, and that just shows you that the contexts belong together and work together. You can have multiple systems in the same graph, but this is just a visual way to keep them organized. For the specific context, spawn does exactly what it sounds like. Here you define how many particles to spawn and whether they come out in a big burst like an explosion or get spawned at a certain rate over time. In initialize, we can then determine how many of these particles are allowed to stay active at one time in our capacity and how they appear in the bounds of 3D space. It could be within a 3D primitive, like a box, sphere, or a torus, for example. And you might want to predefine their starting velocity and lifetime in here as well. Then as we progress downward, we find the update context, where we change the particle's behavior over time. Every frame, do the particles change color or size? Does their velocity change, or does it stay constant? And finally, we send all that information to the output context, where we render the particles to the screen. And here you can determine different types of particles and how they display, what direction they face, and the shaders and textures that you'll use to draw them on camera. Each context is made up of smaller elements called blocks. The blocks implement all these specific operations for each context, and you can create blocks that affect the particle's various attributes, where and how they die, and their position and velocity. The blocks can vary depending on the context, hence the term context, so you'll have different blocks available when spawning, initializing, updating, or outputting. And you'll see that each block has many parameters, all of which potentially affect our particles. To make more complex behavior, you'll notice that a lot of these parameters have input ports. And these input ports can receive input from other elements in the graph called nodes. Just think of these nodes as operations. Chain them together for interesting effects. You can generate numbers or curves or do basic math. Eventually, these feed into the blocks and contexts and affect the particle parameters. The rest of the UI is more about your workflow. We have a blackboard, very similar to the blackboard in Shader Graph. If you want part of your visual effect graph public and exposed in the inspector to allow user input, you'll use this UI element. Click the plus icon to add public properties. We have a long list of things to create in here and expose to the user. Once you have those, you can incorporate that data into your nodes. And you can toggle this whole UI on and off from here. There are also some buttons that are useful for your runtime simulation of particles. Use refresh if you want to make changes to your graph and need them to update in your scene. The select asset button simply helps you find the visual effect graph in the project. And this target GameObject UI allows you to connect a visual effect graph with a specific GameObject in your scene and attach additional controls. If you don't need that dialog, you can toggle it off from here. As your graph becomes more complex, it will take time to compile the asset to disk. You can choose auto compile, so it auto saves every time you make any change, or you can leave this unchecked and press compile only when you wanted to save it. Again, these become more significant as your graph gets larger. Well, this is plenty of material to digest right now. The best way to familiarize yourself with this UI, of course, is just to try it out yourself. Without doing anything specifically meaningful, get used to navigating the user interface, which is again very similar to Shader Graph. Middle mouse pans the workspace. The mouse wheel zooms in and out. Left click to select a UI element, or drag a pick box to select more than one. The A hotkey will frame the entire graph, and the F hotkey will frame a selected portion of the graph. Right click for the context menu, or you could skip a menu and use the spacebar to create a node or a block directly. You'll just need to be over the title bar of a context to create a block, or over the empty workspace of the graph area to create a node. And of course, you also have your standard Control-C, Control-V to copy and paste, Control-Z to undo, and Control-D to duplicate. If you have some nodes that work together, you could highlight those and select Group Selection from the context menu. That makes a node group that you can use to add a name or a simple set of instructions. Or if you need to add more information than that, from the context menu, you could also create a sticky note. Right-click over the empty graph area and select Sticky Note, and type whatever you want in here. This is useful when passing the graph to another person or making mental notes to yourself for review later. Go ahead and try to make some nodes and blocks without worrying about what everything does. Just get used to the UI. If you want to navigate a more complete scene, Unity has provided a nice visual effect graph samples project. You can check the link out from the resources, download the entire project from GitHub, and just open it normally. And there should be a number of fairly good representative visual effect graphs in there, and you can see these UIs in action for real. Okay, well, that's a brief overview of the interface, and that's all we have time for in this episode. Next up, let's actually start doing something with it and create a visual effect graph from scratch. Until then, check out the latest Unity tips and tricks from the Game Academy School website, or if you want more in-depth tutorials, you can get the maximum discount to our premium courses on Udemy here as well. All right, well, thanks for watching. Till next time, I'll see you in the Game Academy.